Okay. I feel like that might be too loud. Maybe that's good. Okay, so we are going to try out Kiro. Not just downloaded in theory. Sure. Can I hit next without doing that? No. Okay. So we're going to go through the docs on this guy once it's done. Okay, we can sign in here. Skip, sure. Yes. Okay, so I want to go to the docs here. And guides. Learn by playing. Okay. Sure. Okay, so we've got what we need here. Okay, so let's read this. Learn by playing. In this guide, you will learn how to use Kiro by completing tasks in the codebase for a sample video game called Spirit of Kiro. 95% of the Spirit of Kiro, the code for Spirit of Kiro has been written by prompting Kiro. You're now, okay, so let's take a look at the code. Let's close this guy for a sec. Okay, so this is a demo. Find unique items. It looks like I need to have a preview. Find unique items. Craft and improve. Sell. Local setup.md. Instructions for how to deploy a local version of the game. Okay, so we've set that up. And then we want to run. So I probably need to be in WSL. Or a dev container. Do I have a dev container here? No. Do I have a Docker file? I have a Docker ignore. Podman, okay. Interesting. So I still need pretty much everything. Let's remove this minimap. The special network is configured so that local metadata service can bind to the specific IP address that ECS uses in production. Okay. Interesting. Services, Ven's credentials to your containers. Environment. Okay. I don't know if I can even run this. Interactions simulated. Spoon and a glass of... Okay, so I need to like set this up. So clone the repo, done that. I have Docker desktop. The credentials I have, but I don't know if I want to use them. AWS Bedrock. So Sonnet. I have to look up the pricing for that. Okay, so I probably can't run this. What did that just do? Oh, I see. Huh. Okay, so can I run this in WSL? Let's take a look. Probably not, or probably doesn't have like... Yeah, that's not it. Okay. This is a nightmare. So like already at the very beginning, I'm not in a Linux machine. I can probably create a dev container. Oh, this is using... I see. So the like... Kiro, it's got the same restriction most of these do, which is... It doesn't have access to... like the normal extension marketplace. So where do we have... Okay. So I don't think it can. Huh. Okay, so I think I need to uninstall this and then install it in maybe, if this even works. Okay, so let's open up one of these guys. Not that. Okay. And then we need to doesn't work with WSL yet, is what I just saw. But I imagine that's not true if I just... I'm sure I can figure that out. Okay. So we did something unrelated to what I wanted to do. Let's see. So apt cache search Kiro. Nothing. Can I look? Is there search for this documentation? Like I'm on Kiro.dev. Can I choose to, what does this bring me to? What is this link? This is what? It's wild that things aren't just links anymore. Like, is this an action? Flex button. Download primary. That's crazy. How? Okay, so another way of doing this, I guess, would be to download this. I know it's VS Code, so in theory, I can just like... Why does that exist? Okay. In theory, I can figure out. Hello. I appreciate that. Gooey Zanbu. What do I want to look up? I guess I want to look up, like, first settings, preferences. Okay, there's too much going on here. Let's just close everything so we can kind of get back to basics here. And then I think we want to do Oh Lord. This is the worst. You're telling me I have to go through each of these? I'm gonna do that just because you're okay. Settings, general. Oh, extension registry. No. Where's like the, yeah, settings JSON. Okay, is there anything here? No. So I like can't. I can't use this. That's crazy. On the left sidebar at the bottom. Oh, here we go. Okay. What is it, cursor? Okay, so VS Code extension marketplace UI. Where is this? Oh, here we go. That's crazy. Okay. So... Oh, you can't... Oh no, I don't want to do that. Show recommended, recently published, popular, featured. Show enabled, disabled, built-in, refresh. Open extensions folder. Okay. Oh. Oh. Okay. Huh. Okay. Can I do that? Close everything. I guess keep that open. And then this is... Oh, I need a product. .json. I don't know. Oh no. So this looks like I just can't do. Oh wait, what is that? Oh no, that's not it. Okay. Can I open that? Like this? Oh, what is this? No, none of that. Okay. So okay, we can have okay, so I know in theory. Okay. Okay, so then I probably want that. Okay, that's great, but I have no idea what to do with that. So I can delete this product.json. I think I have this like service URL. Now there's so much here. I'm just gonna make this full screen for a while. I feel like okay. So in your settings, Okay. And then the VSIX sources. Okay. So you need a name. And that doesn't have autocomplete, so this is type marketplace service URL. Okay. I don't know if I like have access to the hell is that? Okay, so now can I specify? Okay, so let's open up VS Code and then take a look. At what the name of this is. The name is that, I imagine. Okay, so then extensions, and then you just name it. Okay. The hell is this? I'll just try again. I feel like this is not going to work. You know what? Most of this wouldn't work anyways. Okay, so I'll uninstall Kiro and last chance. It's not what I want. This is crazy. This is crazy. The very easy setup here seems to not be so easy. Okay. Kiro dev Linux. Oh, here we go. Okay, so this is where I want to be. And then I guess I want to be here. And I don't know if I can copy this. Copy URL? No, it's using some odd. Okay, well, anyways, I can move it. Users, Andrew. Downloads, what was this? Okay, so. Okay. Depackage. Okay, depackage. Install with dependencies. Oh, okay. Okay. Cool. To use Kiro with the Windows subsystem for Linux, please install Kiro on Windows and uninstall the Linux version in WSL. Yes. Okay. We're in like a weird, potentially okay spot. Oh, that won't work. God. Is there a way that I could do this? If I just install a browser, I guess. Okay. Apt. Chromium Snap. Transitional package, Chromium browser. Shaving a yak. Okay. What does you want to snap? Okay. What time is it? 9:30. So it's probably been like an hour and a bit here. Okay, great. So now maybe. Okay, cool. So we will. This is actually crazy though. Okay. Okay, so yes, close all. So now we can close the or clone the repository, which is kind of crazy if you think about how much we just had to do here. Documentation, guides, learn by playing, code base. Sure. Okay. And then, oh, can I not? Oh, yeah, I can. I can do it manually. Okay. And then installing this or running this was listed somewhere. Okay. Local setup. Cloned it. We have Docker Compose. Okay, so now we can run check dependencies. Okay, cool. And then I'll fix all this later. All right, I'm taking a break. I'll be right back. Okay. So, AWS CLI. What do we got? Okay. Does this take... Oh. Oh, I see. Oh, okay. Oh, you can't? Oh, no, you can kind of see what I'm doing. Okay. Okay, cool. So that is installed, so I can run check dependencies. Okay, AWS. Okay, and then I will do this over here again with one password. Okay. Okay, and now I need to do... Okay. So... Oh, wait. Okay, so here we go. Checking required models. 3. Okay, I don't know. This says I have access to it. Okay, so what's Nova Pro pricing? Bedrock. Oh, okay. So here we go. Nova Pro per 1,000 input tokens is less than a penny. So 10,000 is less than a penny. 100,000 is 8 cents. Okay, and then Nova Canvas, 4 cents per image generated. Yeah, so I don't think I want to do that. And then what's the Titan? Titan text embedding is cheapish. And then what's the Claude? So that's 15 cents. So is this actually cheaper? So Nova Pro is 12308. Claude 2 zeros 2 0. Okay, so try Nova Pro. Where is this? Nova Pro. Nova Canvas and Titan text embedding. Text embedding is V2. Okay. Okay. So I have access to that, I have access to that. I have access to that. Okay, so now if I do is that true? Okay. Anyways, that looks like it's working. So That's weird that it goes to US West too. Okay. Okay, and then okay. So that, in theory, is running. Oh, I press Control C. What is this? Okay, cool. Sure. No. Yeah, fine. New item. What is this called? Spirit of Kiro? Okay, WSAD, E to interact, T to throw held items. Pick up items, inspect them with I. Use E to put in the chest or workbench. We'll figure out whether or not I know how to. Okay, so is this? So like the database isn't working? Oh, I don't have the DynamoDB tables. Bootstrapped. Okay, so that's fine. So here I need to do that guy again. And this needs to be Docker exec in all of these cases. Yeah. In a new terminal. Okay. What? Okay, what about this? Can I just do this? I can. Okay. It's weird that copying Doesn't work the way I would expect it to. Okay. Okay. And what do we have here? Bunch of tag issues. Why? Okay, so found 6 tables to create. This looks very AI built. Server. Items table. Line 105. Oh, weird. So why is it not able to find that? Oh, items table.arn. I mean, are these just warnings? No, probably not. What's the deal here? So, creating table. YAML warning. Unresolved tag. I feel like this is wrong. Where am I reading? I'm reading here. The first time you run the stack will be empty. You can substitute Docker. Okay. Scripts, bootstrap. Okay, what is all this? That like gets in the way? So DynamoDB client. Oh, interesting. This is definitely generated with AI. For local DynamoDB. What containers are running? Like, what am I... and this doesn't really show you what's going on. Oh, maybe it's because I need to. That would make sense. So I'll leave this. I will just force recreate. And we'll like close this just in case that had an issue. And then we will like rerun once this all start. Oh, I guess that's started up. So now here, interesting. Okay, that took quite a while. Okay. There's something wrong with the file system here. This is taking forever. Or maybe it's like verifying if it's already wrote it. But not using the WSL seems to be quite an issue here. I assume this will finish at some point. Also, I wonder... Okay. Whoa. Yes. Still. It's horrible. Okay, that's probably the answer. But why? Oh, why does this like not work? And okay, we'll make this full screen. We'll make this full screen or full screen-ish. And we'll just read this because I don't believe this is true, but... So reading template file. So it's getting the DynamoDB YAML, it's finding all the files or the tables. Unresolved. Okay, so let's take a look at this file, which is app bootstrap local DynamoDB, which is actually the scripts file. So we're at create table. And then error creating table. I don't need this anymore. Oh, it's here. Oh, it doesn't even get to creating or error creating table. So where is creating table? And then await create table and table. And table is a reference to... This is all AI written. Like, this is crazy. I feel like nobody cares anymore. Like, what is this? Right? Console.log. And then some garbage. I feel nobody cares about software anymore. This is crazy. So if we go to await create table, so we assume there's a table. This whole thing is in a try block. So how am I getting an unhandled exception? Is that before? Like, there's nothing really before creating a table, is there? No. Attribute definitions. And then this just has ID as a string, I guess. Oh, and I think the problem with this is like get attribute. It thinks it's a tag when it's running it. I don't think they ever debugged this. Or it's out of date. Switch to the challenge branch. The name of this file is called appsec, but it doesn't. Like, why is it called appsec? This is garbage. Everything is garbage these days. Like, nobody wrote that. Prerequisite dependencies. Yeah, we did this already. We did that. We did that. It also launches DynamoDB local. Okay, let's validate if that's true. Amazon ECS local. Amazon DynamoDB local. Okay. Okay, so we did that. We did that. We did that. Oh, this is a different command, isn't it? Or is it? Exec server bun run. Yeah, that doesn't work. Where's the GitHub? Or do they not have it? Learn by playing. Okay. What the Okay, and then what version of this? 0.1.6, okay. Okay, can I solve this myself? So what is the issue here? The issue is this guy is running this. I need to put the terminal down for a second. So here, okay, let's take a look at the first issue. Oh, what is that? How did that just happen? How did that just happen? Okay, cool. I see. So it's somehow... That's a great representation of me. Okay, and we're back. And now we're like twice the size. Because I guess it finally went to like 4K. Okay, I'm way too big, eh? This is like almost the entire size of the screen. Okay, so what should I do here? I should probably like change it. This is like huge. All right, whatever. We'll leave it for now and then we'll eventually fix it. So I actually don't know Okay, so I can at least try doing this. Where is it? Creating table. So I can do like that. And then I can here, if we go to the bottom, I can do this. Okay, and then we can take a look in theory at the issue. Okay, so table name. Oh. Okay, so then we can do. Okay. That took a while. So this should have written that out way up here. Okay. So key schema. ID. Yeah, what is this actually? So if this is the table, so table name, billing mode, attribute definitions, key schema. Where right, so it's not writing this out. So it's writing create table. Or creating table. It's logging this, but this doesn't seem to have any YAML that is relevant. Parse is running. What's parse? YAML. Very odd. $300 issues. Yeah, this is all not great. Okay, so how do I go to my cloud formation? Templates and get rid of this. Oh, it doesn't even exist? Oh, it's in US West 2. Just randomly in US West 2. Okay. And I think that's... Okay, you know what's weird? The biggest cost is Aurora. Okay, so Kiro is not it. I'm just gonna remove. I'm gonna close this. I don't know why Claude decided to like install itself. I'm going to open up a new Ubuntu tab. And how did I install Kiro? I did the... Okay, so dpackage uninstall. What? Oh. Why can't I do that? Okay. Okay. Apt remove. Okay. And then... Okay, cool. So we are no longer using Kiro. That seems to be not the play. So that sucked. That really sucked. Every... Man, that was so disappointing. That was so disappointing. That was like 3 hours to realize that their own system didn't work. That's crazy. And like every issue, I'm just looking at like the repo issues. They're all pending triage. Like... So what's this, right? I need to read this. Okay, what? Okay. I'm going to read this from start to finish because I feel like I just went through this. It's kind of like the simplest thing that works, I think. Where am I here? Okay. The biggest lesson that can be read from 70 years of AI research is that general methods that leverage computation are ultimately the most effective and by a large margin. The ultimate reason for this is Moore's law, or rather its generalization of continued, exponentially falling costs per unit of computation. Most AI research has been conducted as if the computation available to the agent were constant, in which case leveraging human knowledge would be one of the ways to improve performance. But over a slightly longer time than a typical research project, massively more computation inevitably becomes available. Seeking an improvement that makes a difference in the shorter term, researchers seek to leverage their human knowledge of the domain, but the only thing that matters in the long run is the leveraging of computation. These two need not run counter to each other, but in practice they tend to. Time spent on one is time not spent on the other. There are psychological commitments to investment in one approach or the other, and the human knowledge approach tends to complicate methods in ways that make them less suited to taking advantage of general methods leveraging computation. There were many examples of AI researchers' belated learning of this bitter lesson, and it is instructive to review some of the most prominent. Let's do that. In computer chess, the methods that defeated the world champion Kasparov in 1997 were based on massive, deep search. At the time, this was looked upon with dismay by the majority of computer chess researchers who had pursued methods that leveraged human understanding of the special structure of chess. When a simpler search-based approach with special hardware and software proved vastly more effective, these human knowledge-based chess researchers were not good losers. They said that brute force search may have won this time, but it was not a general strategy, and anyway, it was not how people played chess. These researchers wanted methods based on human input to win and were disappointed when they did not. A similar pattern of research progress was seen in Computer Go, only delayed by a further 20 years. Enormous initial efforts went into avoiding search by taking advantage of human knowledge or of special features of the game, but all those efforts proved irrelevant or worse. Okay, so I have something here. I think we're doing a lot of specialization in software development. And Kiro, even though it kind of sucks generally, is probably an example of this, where we're trying too much to move into a way we used to work. Okay. We're talking about Go. Enormous initial efforts went into avoiding search by taking advantage of human knowledge or of the special features of the game, but all those efforts proved irrelevant or worse once search was applied effectively at scale. Also important was the use of learning by self-play to learn a value function, as it was in many other games and even chess. Although learning did not play a big role in the 1997 program that first beat a world champion, learning by self-play and learning in general is like search in that it enables massive computation to be brought to bear. Search and learning are the two most important classes of techniques for utilizing massive amounts of computation in AI research. In Computer Go, as in computer chess, researchers' initial effort was directed towards utilizing human understanding so that less search was needed, and only much later was much greater success had by embracing search and learning. In speech recognition, there was an early competition sponsored by DARPA in the 1970s. Entrants included a host of special methods that took advantage of human knowledge of words, of phonemes, of the human vocal tract, etc. On the other side were newer methods that were more statistical in nature and did much more computation based on hidden Markov models, HMMs. Again, the statistical methods won out over the human-based knowledge or human knowledge-based methods. This led to a major change in all natural language processing gradually over decades, where statistics and computation came to dominate the field. The recent rise of deep learning and speech recognition is the most recent step in this consistent direction. Deep learning methods rely even less on human knowledge and even more on computation, together with learning on huge training sets to produce dramatically better speech recognition systems. As in the games, researchers always tried to make systems that worked the way researchers thought their own minds worked. They tried to put knowledge in their systems, but it proved ultimately counterproductive and a colossal waste of researchers' time when, through Moore's law, massive computation became available and a means was found to put it to good use. In computer vision, there has been a similar pattern. Early methods conceived of vision as searching for edges or generalized cylinders or in terms of SIF features, but today all of this is discarded. Modern deep learning neural networks use only the notions of convolution and of certain kinds of invariances and perform much better. This is a big lesson. As a field, we still have not thoroughly learned as we are continuing to make the same kind of mistakes. To see this and to effectively resist it, we have to understand the appeal of those mistakes. We have to learn the bitter lesson that building in how we think does not work in the long run. The bitter lesson is based on the historical observations that 1. AI researchers have often tried to build knowledge into their agents. 2. This always helps in the short term and is personally satisfying to the researcher. But 3, in the long run it plateaus and even inhibits further progress. And 4, breakthrough progress eventually arrives by an opposing approach based on scale and computation by search and learning. This eventual success is tinged with bitterness and often completely digested because its success over a favored human-centric approach. One thing that should be learned from the bitter lesson is the great power of general-purpose methods, of methods that continue to scale with increased computation, even as the available computation becomes very great. The two methods that seem to scale arbitrarily in this way are search and learning. The second general point to be learned from the bitter lesson is that the actual contents of minds are tremendously, irredeemably complex. We should stop trying to find simple ways to think about the contents of minds, such as simple ways to think about space, objects, multiple agents, or symmetries. All of these are part of arbitrary, intrinsically complex outside world. They are not what should be built in, as their complexity is endless. Instead, we should build in only the meta methods that can be find and capture this arbitrary complexity. Essential to those methods is that they can find good approximations, but the search for them should be by our methods, not by us. We want AI agents that can discover like we can, not which contain what we have discovered. Interesting. I need to read this last paragraph again. The second general point to be learned from the bitter lesson is that the actual contents of minds are tremendously, irredeemably complex. We should stop trying to find simple ways to think about the contents of minds, such as simple ways to think about space, objects, multiple agents, or symmetries. All these are part of the arbitrary, intrinsically complex outside world. They are not what should be built in, as their complexity is endless. Instead, we should build in only the meta methods that can find and capture this arbitrary complexity. Essential to these methods is that they can find good approximations. Okay, but the search for them should be by our methods, not by us. Okay, so that talks about crystallizing some type of heuristic. We want AI agents that can discover like we can, not which contain what we have discovered, right? So that's saying effectively like make declarative the act of planning instead of feeding planning into the inputs, I guess. Building in our discoveries, I needed to think about a better example for that. Building in our discoveries only makes it harder to see how the discovering process can be done. Okay, so the last few sentences are probably the most useful to unpack. Essential to these methods is that they can find good approximations. But the search for them, the search for these approximations, should be by our methods, not by us. So we should understand the methods in which we find good approximations. And we should let AI agents conduct those. Okay. How is this organized? Small. You were libertarian because you abhor violence. When a neighbor isn't willing to contribute as much to social projects as you are, you'd never think of using a gun to force them to contribute, hiring an armed guard, threatening. Okay, using the government. If two people have agreed with no violence, you never think of. Okay. Oh, I see. Interesting. The one-step trap is the common mistake of thinking that all or most of an AI agent's learned predictions can be one-step ones, with all longer-term predictions generated as needed by iterating the one-step predictions. I have no idea what that means. The most important place where the trap arises is when the one-step predictions constitute a model of the world and how it evolves over time. It is appealing to think that one can learn just a one-step transition model and then roll it out to predict all the longer-term consequences of a way of behaving. The one-step model is thought of as being analogous to physics or to a realistic simulator. The appeal of this mistake is that it contains a grain of truth. If all one-step predictions can be made with perfect accuracy, then they can be used to make all longer-term prediction with perfect accuracy. However, if one-step predictions are not perfectly accurate, then all bets are off. In practice, iterating one-step predictions usually produces poor results. The one-step errors compound and accumulate into large errors in the long-term predictions. In addition, computing long-term predictions from one-step ones is prohibitively computationally complex. In a stochastic world, or for stochastic policy, the future is not a single trajectory, but a tree of possibilities, each which must be imagined by weighted by its probability. As a result, the computational complexity of computing long-term prediction from one-step predictions is exponential. What is a one-step prediction? Also known as the one-step ahead prediction, is a type of forecasting where you predict the next value in a time series based on the immediately preceding. Okay, so this is like the entirety of large language models. Okay. Long-term predictions from one-step ones is prohibitively computationally complex in a stochastic world. Or for a stochastic policy, the future is not a single trajectory but a tree of possibilities, each of which must be imagined and weighted by its probability. As a result, the computational complexity of computing a long-term prediction from one-step predictions is exponential. Yes. In the length of the prediction and thus generally infeasible. The bottom line is that one-step models of the world are hopeless, yet extremely appealing, and are widely used in POMDPs, Bayesian analyses, control theory, and compression theories of AI. The solution, in my opinion, is to form temporally abstract models of the world using options and GVFs as in the following references. I hold that AI has gone astray by neglecting its essential objective, the turning over of responsibility for the decision making and organization of the AI system to the AI system itself. It has become an accepted, indeed lauded form of success in the field to exhibit a complex system that works well primarily because of some insight the designers have had into solving a particular problem. This is part of the anti-theoretic or engineering stance that considers itself open to any way of solving a problem. But whatever the merits of this approach as engineering, it is not really addressing the objective of AI. For AI is not enough merely to achieve a better system, it matters how the system was made. The reason it matters can ultimately be considered a practical one of scaling. An AI system too reliant on manual tuning, for example, will not be able to scale past what can be in the heads of a few programmers. This, it seems to me, is essentially the situation we are in today in AI. Our AI systems are limited because we have failed to turn over responsibility for them to them. Please forgive me for this, which must seem a rather broad and vague criticism of AI. One way to proceed would be to detail the criticism with regard to more specific subfields or subparts of AI. But rather than narrowing the scope, let us try to go the other way. Let us try to talk in general about the longer-term goals of AI which we can share and agree on. In broadest outlines, I think we all envision systems which can ultimately incorporate large amounts of world knowledge. This means knowing things like how to move around, what a bagel looks like, that people have feet, and knowing these things just means that they can be combined flexibly in a variety of combinations to achieve whatever the goals of the AI. If hungry, for example, perhaps the AI can combine its bagel recognizer with its movement knowledge in some sense so as to approach and consume the bagel. This is the cartoon view of AI as knowledge plus its flexible combination, but it suffices as a good place to start. Note that it already places us beyond the goals of a pure performance system. We seek knowledge that can be used flexibly, i.e. in several different ways, and at least somewhat independently of its expected initial use. With respect to this cartoon view of AI, my concern is simply with ensuring the correctness of the AI's knowledge. There's a lot of knowledge, and inevitably some of it will be incorrect. Who is responsible for maintaining correctness, people or the machine? I think we all would agree that, as much as possible, we would like the AI system to somehow maintain its own knowledge, thus relieving us of a major burden. That is very interesting, because I think that's one of the problems I'm seeing right now myself, is if you have to be responsible for the system, then you have to know how the system works. And if we allow ourselves, but it's hard to see how this might be done. Easier to simply fix the knowledge ourselves. This is where we are today. I agree. I am disillusioned with how difficult that was to set up. I'm going to come back with something better in the future. I already have a few thoughts. Okay, thanks. Bye.